Okay, the subject matter here is not very interesting, but it's a good use of what we've just learned. Suppose you tear open the corner of a bag of M&Ms, milk chocolate candies, and you pour one candy into your hand and observe the color. According to the Mars Incorporated, maker of M&Ms, this is the probability model for their different colors. They're not all equally represented. There are what's the one that's there the most? There's more blue and there's more orange than anything in this picture. And this guy that wrote this book actually asked them why. I don't know where I heard this, but the reason they say why they're not all just the same is because apparently this mix, when put on a piece of paper like this, is the one that draws your eye to it and makes you want to buy it the most. It's an advertising trick. Okay, explain why it's a valid probability model. Well, you guys, you only have two rules for probability models. You got to list the outcomes, and you got to write them, and they have to add up to 1. So if you're asked, why is this a valid probability model? Did you list them? Yeah. This is what you really have to check. Do these add up to 1? So I'm not going to bother with it because there's decimals and calculators, and I can't even count to 3 today. So I'm just going to say if I add these up, they definitely add up to 1. Part B, find the probability you don't get a blue M&M. Okay, now here's where you could do something stupid, so pay attention. You could go, nope, I don't want the blue, I want this one, or this one, or this one, or this one, or this one. And they can't happen at the same time, so they're mutually exclusive, so I'm allowed to just add them together, right? Or you could just go, it's 1 minus the blue. 1 minus 0.207 is a lot quicker than adding all 5 of these. Didn't count that right either. So that would be 0.793. 0.793. And so when you go here and look what they did, they actually went and found 1 minus blue, 1 minus point, and 0.793. Over here, they actually added them all up and showed that they equal 1. That's nice of them. Okay, and then the last one they ask, what's the probability you get an orange or brown? Because they can't happen at the same time, you are allowed to add them, and you get 0.329. So there you go. We're off to a good start. You got to check your understanding. So I think this is a good opportunity for you to actually, show that you know what's going on here. So I'm going to stop. I'm going to have you check your understanding, and I'll write down the answers. We'll compare in a second.